Well, hello, I'm Ralph Gable of the Electronics for the Inquisitive Experimenter YouTube channel. In the previous video, I presented a simple but effective and inexpensive way to create an antenna support for a simple wire antenna. And for many people, this is all that they might need. But then there are those of us that want to put up a more elaborate antenna. And a lot of this is driven by the desire for better performance in our antenna. And this is we start looking to put up some sort of tower. In this video, I'm going to talk about the basics of putting up that tower. I will cover the planning for it, the preparing for it, and the putting it up. Now, this is not going to be an everything that there is to know about putting up towers kind of video. Thus, I'm not going to go into the details of how to do each of these steps, as this is often very specific to the particular tower you're looking to erect. For those details, I will point you to the tower manufacturer. I will emphasize some of the details that are most often overlooked or glossed over by folks. So pay attention. Now, our first reference for putting up that tower, adding that antenna and rotator and so on, is always the manufacturer's instructions. Now, if you would like an additional book, a good reference for putting up a tower is Up the Tower, The Complete Guide to Tower Construction by Steve Morris, K7LXC. Now, if you have questions or comments, please feel free to add a comment to this video. If you find this video helpful, please click on the like and don't forget to subscribe. So let's begin with the primary specification of interest. Well, one of the primary specifications for a tower is its wind load capacity. There are actually three distinct types of wind loads. There is uplift, there is shear, and there is lateral. Uplift wants to lift the building or structure up and off of its foundation. Shear deals with winds coming from opposing directions, wanting to shear the building or structure in two, much like a pair of scissors will cut paper. Lateral wants to blow the building or structure over. Now, when we look at the specifications for the tower, what they will tell you is its maximum rated wind speed in miles per hour or kilometers per hour, and any additional antenna limits, which include things like the wind area in square feet or square meters, wind load in pounds or kilograms, weight in pounds or kilograms. Now, these maximum antenna values include the antenna, the rotator, and anything else that you put on the top of the tower. They may also tell you how far above the tower they expect the antenna to be. In the case of the antenna specifications that I'm looking at right now, this is just 1 foot. Meeting these specifications depends on the tower installation to be performed in accordance with some very specific requirements. More on this later. So what about used towers? Well, this, my friend, is a real gamble. You cannot easily know the internal condition of the structure of the tower sections. Tower sections may look good with the naked eye, but be twisted or bent enough so that they don't fit with the other tower sections, or rusted enough that they're not nearly as strong as their newer cousins. So be careful. Inspect thoroughly. Assume nothing. Now, I'm not saying to never use them. I am saying to be sure of what you're getting. Now, what are the two broad kinds of towers? In short, there are two very broad spectrums of towers. The first are the self-supporting towers. Now, the biggest advantage with these is that there are no guy wires to deal with. You can also get them in designs that let you telescope them down and tip them over, so tower climbing is all but a thing of the past. The biggest disadvantage is that they are more expensive to buy and install. The second major type are the guide towers. The biggest advantage to these is that they are less expensive to buy and install. Furthermore, there is a ready supply of used tower sections available, making procurement even cheaper. The biggest disadvantage of guide towers is that you need someone to climb the tower to install or do any maintenance on it. Beyond this is dealing with the guy wires that they require. Because guide towers are almost ubiquitous in the amateur radio world, the emphasis in this video will be on these. Now we get to dive into more detail about planning your tower installation. So what came first, the tower or the antenna? Well, that depends entirely on what is the most important to you. If you're set on having a very specific antenna, then you choose the tower and the tower height to accommodate the antenna. If you're set on a specific tower and tower height, then you choose the antenna that the tower can accommodate comfortably. In either event, you have to ask these two questions. What wind speed do I want my tower and antenna to survive? And how tall do I want my tower to be? Now, for the sake of argument, let's say that I was able to get some Rohn 25 tower sections to provide me with a 60-foot or 18-meter tower. Now, if I procured these as used tower sections, then I would go to the manufacturer's data sheet for the tower model and verify that these sections are what they purport themselves to be. For instance, Rohn 25 and Rohn 45 tower sections, well, they look pretty much identical on the surface, but their performance is far different. Trust and verify. Now, with this example, I want my tower and antenna to be able to survive 90 mile an hour or 145 kilometer per hour winds. My first step is to go to the Rohn website and download the catalog for their guide towers. I've put a link to the current catalog in the description for you. I scroll down through the pages to find the Rohn 25G towers. This is found in 3 sections divided by wind speed. The second one is the 90 mile per hour for the Rev F section. Now I move down through the tables to find the height I am looking for. You will see the illustration on the left which shows guy wire placement, type, and initial tension. It also includes 3 boxes next to the tower which give the wind load capacity of the tower, assuming that it has been installed per the manufacturer. The one with the beveled corners is the one for the Rev F wind load specification. Here I see that I'm allowed up to 12.2 square feet or 1.13 square meters of antenna and rotator wind load for my 60-foot tower. Now I know what I'm limited to in my antenna and rotator selection. I'll start with the rotator as this is a more fixed wind load. Well, we choose our rotator based in part on its wind load capacity. When in doubt, go stout, as I've heard, and this applies to rotator selection. The tower is capable of 12.2 square feet or 1.13 square meters of wind load. The cheapest rotator on website has a wind load capacity of 10 square feet or 0.93 square meters. I want my rotator to have at least as much wind load capacity as my tower, so I have to go to the next one up. This one has a wind load capacity of 21.5 square feet or 2 square meters. So I choose this one. I go to the manufacturer's website and download the specification sheet for this rotator. According to the data sheet for this rotator, they recommend that you allow a safety margin of 40% in the wind load to accommodate wind gusts. Doing the math, 21.5 times 0.6 equals 12.9 square feet or 1.2 square meters. Thus, we want to limit the wind load of the antenna to about 13 square feet or 1.2 square meters. And well, this is already above the capacity of the tower, so we stick with the tower wind load limit. Now, what about the antenna? Our first step in antenna shopping is to determine the maximum wind load our tower can deal with. The tower wind load limit includes the wind load of the rotator as well as the antenna. Thus, we might have 12.2 square feet wind load limit for the tower, but we do not have 12.2 square feet of antenna wind load to work with. So, how much do we subtract out for the rotator? Well, unfortunately, they do not specify the actual wind load of the rotator itself. They only give the wind load that it can accommodate in the antenna. At least I didn't find it in the data sheet that I was looking at for the rotator I chose. So I did a very quick calculation using the surface area of a cone. I divided this by 2 because the wind is only pushing on one side, and then not even at 90 degrees to that one side in all locations. As a result of this broad estimate, I would accommodate the rotator by subtracting 1.5 square feet or 0.24 square meters from the tower specification for the wind load of the rotator itself. This leaves us with 12.2 minus 1.5 or 10.7 square feet or about 1 square meter of antenna. I'd also want to apply the same 40% safety factor to the tower that the rotator people applied to the rotator capacity to make room for wind gusts that exceed the 90 mile per hour wind speed specification. So this gives us a total of 10.7 times 0.6, which equals 6.42 square feet or 0.6 square meters for the antenna itself. Now, let's go antenna shopping. A rotatable dipole comes in at 1.3 square feet or 0.12 square meters. I can go bigger. Well, what about a hex beam antenna? That is, well, 3.5 square feet or 0.33 square meters. Do I want to do more? Well, then there is the tri-band 3-element Yagi or beam antenna. It has 4.6 square feet or 0.43 square meters of wind load. I could even do more. And on goes the search until you either reach your wind load limit, your cost pain threshold, or the pain benefit limit. At this point, you have your tower with its top section and concrete base, your rotator and your antenna. Don't forget your mast. And now that we know the what of the installation, we can plan on the how of the installation itself. Well, planning the how of installation begins by going back to the manufacturer's data sheet, drawing, or catalog. So what do we have to plan? Well, let's start from the ground up, or should I say, under the ground up, using the previously selected tower as our example, the Rohn 25G Rev F. Now, there are 2 aspects to this part of the planning. The first part is the foundation below the tower itself. We start with the table where we looked up the wind load capacity. Over on the far right of this table is a cell labeled base. For our 60-foot tower, they have CB1G. This sends us down to the page where they illustrate the standard base piers. You will find the table on this page which specifies how this is going to be constructed. Looking at the CB1G row, we discovered that this tower with this height requires a piece of concrete that is 2 foot 6 inches or 0.76 meters square by 4 feet or 1.2 meters deep. But this is not just a block of concrete. There is a rebar cage that is to be embedded in that block of concrete. And lastly, there is a 3/4 inch or 19 millimeter diameter by 12 inch or 30 centimeter long galvanized steel pier pin that aligns the base plate to the pier, which is located in the geometric center of the concrete foundation. But we're not done. There are the guy anchor blocks. Yep, more concrete. When we look once again at the table for our 60-foot tower, we find that the recommended initial tension on the guy wires is supposed to be 399 pounds or 1,775 newtons. It is really obvious that a simple stake in the ground is not going to accomplish this task, no matter how big that stake might be. That simple stake will just rip right up and out of the ground. This is why they specify a rather large block of concrete buried in the ground. For this particular 60-foot Rohn 25G tower, each of the 3 blocks used to anchor the guy wires is supposed to be 4 foot or 1.22 meters long by 6 foot or 1.83 meters wide by 1 foot 6 inches or 0.46 meters tall. It is buried with its bottom 4 feet or 1.22 meters beneath the surface of the yard. But like the tower's foundation, it is not just a simple block of concrete. It is steel reinforced and has the anchor rod embedded in the concrete block as shown in the illustrations in the catalog or data sheet. Having your guy wires and guy wire anchors installed according to the manufacturer's specifications is absolutely a must if you expect your tower to perform as it was designed. Yes, many people have gotten away with taking shortcuts, myself included. But now that we know, well, let me just say this. Suppose we had a windstorm and the tower comes down, doing damage to someone else's property, or, God please forbid, someone getting killed, and the tower has not been installed according to the manufacturer's instructions. Then guess who becomes liable for all of the damages and maybe potentially chargeable under the law for negligence? Well, let's talk about guy wires now. Guy wire tension is supposed to be 1/10 of the tensile strength of the guy wire itself. The Rohn folks recommend using 3/16 EHS guy wire with a tensile strength of 3,990 pounds or 17,748 newtons. This means that the guy wire tension should be 399 pounds or 1,775 newtons. And this is exactly what the table in the Rohn 25G catalog recommends. Now, rope will not do as guy wires. Apart from the tensile strength of the rope being in question, rope will stretch significantly over time, and soon there won't be anything close to the right amount of tension. Besides this, it will degrade with ultraviolet light, meaning that its tensile strength will degrade with time. So I emphasize once again, use what the tower manufacturer recommends and tighten them to achieve the recommended initial tension. For this Rohn 25G 60-foot tower, I will need no less than 425 feet or 129.5 meters of guy wire according to their table. The table for this height tower shows you the approximate lengths needed for each guy wire. Now here's an important note. Make sure that the guy wire lengths are non-resonant at any frequency that you will be transmitting on. Separate the guy wire lengths with properly rated insulators. Resonant lengths of guy wire will become part of your antenna system and will significantly impact the performance of your antenna. You will also need beefy turnbuckles to tighten the guy wires to their required tension. When putting the guy wire assemblies together, you will be using what we often call U-bolts, but the real name for these is wire rope clamps. You can get galvanized steel or stainless steel versions which are specifically made for the size of guy wire you are using. Do not get the ones made of aluminum. Now, these have two sides. We have the U-bolt side and the saddle side. When installing these on your guy wire, make sure that the saddle side is on the guy wire that has the tension on it, not on the free side. The side that has the tension on it is called the live side. The loose end is called the dead side. Further, you will need 3 of these for each connection. The clamps are installed side by side. The guy wire goes through the insulator or other hardware and extends past this another distance, and this distance depends on the size of the guy wire being used. For the 3/16 EHS guy wire, this would be 3.75 inches or 9.5 centimeters. Leaving room for the other 2 clamps, the first clamp is applied away from the loop and snugged into place, keeping the 2 nuts even. The second is installed as close to the loop as possible and snugged into place. The third, then, is installed between these 2. These should be all cozy with one another. Now, taking turns between the nuts, tighten them all evenly until they are all tightened to the recommended torque. Now, the last of the planning. Well, now we come to all the other stuff and preparing for the actual tower installation. Now, here's a checklist for you. First, be sure that all of the concrete is properly poured and the guy anchors are installed according to the manufacturer's instructions. The concrete should have properly cured for maximum strength. The person climbing your tower does not want to risk their life doing you a favor because you took shortcuts. I have known of a tower climber who ended up in the hospital for these very reasons. The tower tipped over on him with him attached because the owner took shortcuts. Number 2, install all of the ground rods as specified by the manufacturer at both the tower base and the guy wire anchor points. Third, prepare all of the guy wires per the manufacturer's specifications. Do not forget to break up the guy wires into lengths that do not resonate at any frequency that you'll be transmitting on. Separate these lengths with properly rated insulators. Number 4, pre-fit all of the tower sections together laying flat on the ground. This is especially crucial if you're going to be using used tower sections. I've seen real battles while trying to get tower sections to mate while the climber is hanging 30 foot or more off the ground. Used tower sections can be warped. Once you're sure that all of the tower sections fit nicely together, carefully mark each section so that everyone knows which section goes first, which goes second and third, and so on, but also which leg matched with which leg when they were fitted together on the ground. Number 5, the antenna must be completely assembled and tested. You do not want to get it up there and then have to ask your climber to come back a week later to bring it down so that you can fix it. Number 6, prepare and test the feed line. Make sure that it's in good shape and that the terminations are done properly. Number 7, get the rotator and the rotator control cable ready to go. The cable must be terminated as needed to interface with the rotator. Know what direction the rotator is currently pointed. This way, your tower climber can get the antenna pointed in the right direction when they install it. Number 8, if there are any other cables that might be needed, make sure that they all have the right connectors on them and that the cable has been tested to be good. Number 9, make sure that all of the needed hardware is there. I have seen ready packaged tower hardware kits missing a crucial nut to assemble the tower. Assume nothing. Open everything. Count everything. Go over every place where hardware might even remotely be needed and make sure that it is there. Not only that, it's a good idea to have spares. Stuff can be dropped accidentally and lost in the grass. Number 10, have some anti-corrosion grease there for assembling the tower sections. Don't forget to have some cloths or paper towels available for wiping excess grease off of things and hands. Number 11, buy some good quality UV-resistant cable ties. Now, these are usually black in color, but read the label. Just because they're black doesn't mean that they're UV resistant. Number 12, have a roll or two of quality electrical tape, and I emphasize good quality heavy-duty stuff. If it's inexpensive, it probably doesn't meet this criterion. Number 13, you might want some rubber mastic tape for sealing your connections against the elements. No water is getting through this stuff if it is properly applied. So just remember, your tower climber is there to supply expertise, not supplies, not hardware. They will bring some of their own tools, but be ready to help out with some of your own if special circumstances arise. Now, we're ready to raise the tower. The single most important priority in this process of raising a tower is safety, safety, safety. If there is any reason at all that the tower climber does not feel that they can do the job safely, then it is their responsibility to choose not to do the task. On the other hand, if you feel that it is not safe and they're going to do it anyway, do the climber a favor and tell them not to do it. The owner and the tower climber must be in full agreement that it is safe to accomplish the task, or it just does not get done, period. Now, some of the factors that can affect this is weather, such as it's too windy, or it's too cold, or there's snow, or there's ice, or there's rain. There could be mechanical issues with the base or with the guy wire anchor points, the condition of the tower sections themselves to be put up, among others. The tower climber must have their own safety equipment, such as a climbing harness or belt. If they are going to do this task without the proper safety equipment, tell them that you do not want them to do it. Now, assuming all is well, what's next? At this point, you will have accomplished the checklist that I've provided. The tower climber has the prerogative to choose not to move forward with the task if anything on that checklist has not been accomplished. And this is especially true if it in any way affects safety. Give the tower climber time to get set up. Now the process. Remember, the tower climber is the boss. He's the one calling the shots unless they designate otherwise. The ground crew provides supplies, lifts things into place, does whatever is needed to support the activities of the climber. There should be no less than one person on the ground crew, but preferably 2 or 3, depending on what's being done. The tower is put up one section at a time. The nipples at the top of each section are first given a coat of grease, and then the section above it is slid down on top. 2 bolts are installed in each leg as with the Rohn towers. Then we wipe off the excess grease that exists around the joints. As each section is installed, a coat of grease is put on the nipples at the top of the last installed section prior to installing the next section. This assures easy disassembly when the time comes and helps prevent corrosion, which can degrade the mechanical strength of the tower. Once the first bottommost section is in place, the climber will install what is called a gin pole. This is used to lift the next section up into place above the last installed section. It has a pulley at the top and a rope through this pulley and down through the center of the pole. The ground crew is responsible for managing this rope per the climber's instructions. The climber attaches the gin pole to one leg of the already installed tower section. It is extended up above the top of this section by about 10 feet. The ground crew uses a rope which runs through the center of the gin pole to lift and support the new section while the climber positions and secures it in place. Additional ropes may be used to prevent the section being lifted from snagging on things or banging up against buildings or other structures. This process continues one section at a time until we get to a place where guy wires are supposed to be installed. The climber attaches the guy wires to the tower with the manufacturer's recommended hardware. At this point, they may choose to descend the tower to help with the next step. The other ends of the guy wires are attached to the guy wire anchor points and secured in place. Now, while monitoring how level or plumb the tower is, the tension on the guy wires is increased one at a time to the tension specified in the manufacturer's instructions. So, how do you know how much tension is in the guy wire? Well, there's a few ways to accomplish this. You could buy or rent a special device that will tell you that, but this costs some real money. There is the pluck the wire and count the vibrations method. Depending upon the length, weight per foot, and tension of the guy wire, it will vibrate at a given rate, just like with a guitar string when you pluck it. The greater the tension, the faster the vibration. Now, I hope you can count fast. This one only works if it is just the wire with no insulators. And then there is the old mechanic's trick, what I call the deflection method. All you need for this is a fish scale like this one. So how does that work? Well, we attach the fish scale to the guy wire at a specific location on the guy wire, like 6 feet or 1.83 meters from the guy wire anchor point. Now we carefully pull at right angles to the original guy wire position until we reach a specific deflection, say 3 inches from its original position, or 7.62 centimeters. Now we read the fish scale. If our wire is 56 feet long and we read 18.6 pounds, or 8.44 kilograms, then the tension in the guy wire is 399 pounds, or 1,775 newtons. The downside to this is that the math to calculate this is a little intimidating. For this reason, I have written a computer application that will do this calculation for you. See the description for a link to the zip file which contains this app. I've also provided an Excel spreadsheet that does the same thing. The link to the zip file which contains this is also in the description. Now, I have carefully researched and tested these to provide the right values. I have enough confidence to use them for any tower that I would erect for myself. However, I provide no certification for its accuracy. Use at your own risk. Now, once all the guy wires are properly in place, then this process of installing more sections and guy wires continues until the final section, rotator, mast, antenna, and all the cables are in place. Well, we have finished skipping along the high points of planning for and putting up a tower. I hope this video has given you enough information to know where to look to get any specific details that you need to proceed on your own tower project. If you found this video helpful, please click on the like and subscribe to the channel. Thank you so much for watching. Until next time, Toodle-Oots.